Talk about an overarching principle here. Now please, and all PowerPoints and everything I use in class will be posted on the website. So like this graphic, don't try to draw it. I mean, if you want to, you can. But you'll have all this stuff available to you after class. I want to give two more definitions and then some sub-definitions before we get into more measure and display of data. Although this is a display of data. Descriptive stats. Very often, this is what you read about in, say, the business section of a paper. What happened in the Dow today? How did the markets close? Kind of thing. So it's a bunch of data that you went and collected, and then you report on it. So I can do that with the 2012 presidential election. It's going to be fun to do it with the 2016 one once that rolls around. Or maybe it won't be. We'll see. I don't know. It'll be fun to analyze the data, regardless of your political party. But the 2012 presidential election, the results were Obama got 50.6% of the popular vote once all the votes were in and counted. And Romney got 47.8% of the popular vote once all the votes were in and counted.
And that's the majority of the populace. So.
The majority of those who voted.
Yeah.
That's always the trick with voting, right? Because less than half the population, I think, votes. Right. So of those who voted, that's what came in. It'd be tricky to say what would happen with the population. Statistically, I do say that. Yeah. Except for, can you hold that question for a second, Scott? That is such a good point. And bring it back up, parameters and statistics.
I'm holding on to it.
That's a great question. I don't want to jump into it right now because technically speaking, we can say this is 50.6, 47.8 because according to they counted every vote. So it's not so much that it's about 50-50, but it's exactly that because they counted every vote. They can't always do that, but they did for this. Mm-hmm. That doesn't add to 100 though, does it? It doesn't. So did they count wrong? Thank you. Tell me your name. Riley, thank you. There aren't just two parties. It'd be hard to, it's hard to believe there are just two political parties in this country. But there are like a dozen. But the other 10 collect about 1% of the vote. With one exception. Do you remember when you guys are too young to remember Ross Perot. Ross Perot collected like 20% of the popular vote the year he ran. And he screwed everything up. We can talk about that if you want. We can talk about that if you want. But he got a huge chunk of the vote, which is kind of amazing to think about. So, but other than that, I mean, Ralph Nader and the other independents really don't generate that much popular vote. The electoral vote apparently is the one that means everything. So, right, this is, if you win a state, you get all of their population's votes. So it's a way of, I don't know what the hell it does actually, we can talk about that over coffee too. But what you see here, this map, is the electoral results state by state of the 2012 elections. Blue states went to Barack Obama, red states went to Mitt Romney. Now some of you are kind of furrowing your brows right now because you're like, wait a minute. Obama was 61.7, Romney was 38.3. That does add up to 100, which it should. But that doesn't look like 61.7% of the states.
But certain states have more, Alicia.
Alicia. I'm trying to learn. Go ahead, Alicia.
Certain states have more electoral votes.
Why?
So they count for it. Bigger population.
More population. So what a very clever statistician did was they redrew the map. They redrew the map so that the states themselves were the same size as relative populations. Now I want to go back real quick to the previous map. Find Wyoming. It's one of the rectangles. Find Delaware, my home state. It's okay if you can't. It's attached to Maryland and kind of attached to Pennsylvania. It's this little tiny, they call it the Diamond State. This little guy right here. Chesapeake Bay. Delaware River, Chesapeake Bay. Very, very pretty. Well, kind of. Not as pretty as here. Okay, now watch when we adjust for the populations. Can you find Delaware now? Not so hard to find Delaware anymore. And it's also a little bit harder to find Wyoming. Because Wyoming now takes up less area than Delaware on this map, according to the statistician. I would have drawn it a little bit differently. But Wyoming has fewer people in it than Delaware. Wyoming is the least dense state in the Union by area. I think even more than Alaska. Definitely of the contiguous 48. But no Wyoming? There's nothing there. It's beautiful. There's more fence than people. It's a beautiful place. Windy, snowy, beautiful mountains, the Wind River Range is there, the Teton Range is there, Yellowstone National Park is there, and there's like 12 people. So now do you see the 61-38 split a little better?
Oahu's got 1.5 million.
Oh, that's right. I forgot they didn't put Alaska and Hawaii on here. They did not.
They have Hawaii's islands, it looks like.
I think that's off the coast of Cali. They left
okay.
off Alaska and Hawaii on this map.
Okay.
Yeah, I forgot about that. I was meant to
It's
fix that.
huge. I mean, that
It is
population
compared
is
to the
huge.
area, right? Exactly. So what then a statistician cleverly did was they decided to go by county. So this is the same broken down by county to look at electoral votes. Now this looks even worse for Obama, doesn't it? Because there's even less blue. But then you realize, can you find LA County in that map? Or can you find Manhattan or New York City in that map? How about now, can you find them? When you adjust it for population, can you find New York? Look for New York. It shouldn't be too hard. It's that. Right? Go back. Find New York there. Kind of tricky. I can see Connecticut. Find New York. New York is the largest city in the United States. Something like 15 million people or something ridiculous like that at the peak of its day. Well, LA is a close second. It's also a larger area. But the population density of New York is, anybody ever been to New York City, Manhattan, Long Island, Strong Island, Brooklyn, Queens? The population density is overwhelming. Pretty fun too. And it's also fun to leave, come back here where it's quiet. It's fun to leave and come back here where it's quiet, where I had to stop for a family of quail crossing the road this morning. Bend, there you go, ones, there you go. Oh, you too, you go. Very soon. So, what's this? That's Chicago, isn't it?
Yeah.
That's Lake Michigan. Let me go back up.
Lake Michigan.
That is Chicago. Is that Lake Michigan or Lake Superior? I forget which one is which. Michigan. So that's got to be Chicago right here. Yep, Chicago, Seattle. Or Seattle, Portland, Seattle, San Fran, maybe? No, San Fran. What the hell? That's not, where's LA? I'm getting confused. It's somewhere over there. But you get the point, right? You understand the point when you adjust for population. People don't uniformly evenly spread themselves through a country. Find Oklahoma. Have good luck finding Oklahoma.
Like that.
This was clever too. I think it's possible to get a little ridiculous with the statistical displays. The same statistician decided to not weight each county just by party, but by percentage of party. So in other words, if LA County was mostly Democratic with some conservatives, some Republicans, he made it a shade of purple. So the more purple, the more split they were. The more red, the more conservative, the more blue, the more liberal. Fair?
That makes a lot more sense.
Exactly. It makes sense until you do that with it. If you showed somebody this picture and said, you know what you're looking at, they'd be like, I think I'm looking at my third grader's heart project. You wouldn't know that was the United States electoral map from 2012, would you? So I think this gets a little ridiculous. My personal favorite, this is just me speaking, my personal favorite is still this one. Because you can tell what you're looking at. If you look at it for a couple seconds, you're like, oh, it's the United States, it's the 48 contiguous. Oh wait, now why does it look like that? And then you start thinking about it, oh, it's got to be population, oh, it's blue and red, right, electoral stuff. So. But this is all what's called descriptive. Because that happened, right? No matter how you present it, that happened in the 2012 election. When I was talking about this in 2011, it wasn't descriptive because it hadn't happened yet. In 2011, we were predicting what was going to happen in 2012, just like they're already doing now for 2016. They can't get Obama out of the office quick enough, can they? I was talking about 2016. It's got 2 more years. But we're now guessing what's going to happen in 2016. That isn't descriptive. That's when you're forecasting, and that's the next kind of statistics. Let me get up to it here. That's the next kind of statistics, which is interesting, and it's predominantly what 244 is based on. 243 is basically based within the realm of descriptive. And what Scott brought up before about the 50-50 is more based on the inferential side. That's why I wanted to save your awesome question for this. Great question. So what it does is it makes a prediction, which means there's more uncertainty in what you're saying. And the way you make the prediction is you draw a sample, hopefully a random sample. We'll talk more about that soon, as in the next 10 minutes, from a certain population. Assuming your sample was drawn well and randomly, you're going to get a pretty good snapshot of your entire population. Ask me that question, Taryn. Are you just processing? You're not buying something. Go for it.
The question's getting there.
Oh, good!
It's not full form yet.
And I apologize. Some of you guys know me already. I tend to predict your questions. I watch faces as we're having a discussion. It's like, yes, you do. And if I see you like forming a thought, a lot of times I'll interrupt it, unfortunately, because I'm like, what are you thinking right now? I was thinking I was hungry. So if that annoys you, just tell me, I'll stop doing it. But I like to watch your faces for signs of, you know, oh my, there it is.
I
I didn't
guess
screw it
it
up.
goes back to my question for 105, how do you know you have enough data from a random sample for it to be legit?
And I'm gonna push it down the pipe again. I can give you a calculation right now if you want. You want a calculation? Okay. So, there. That's your calculation. You're taking 244, right? Yes! That will make a lot more sense once we have these tools under the belt. That's the calculation
It's
for.
only 243 and 105.
No. But and there's the calculation. But it's not gonna make any sense to you right now at this moment. Can we come back to your point in a second? Just in a second when we get to the next page of this with the Gallup poll. No. This is not like Snatch. This is not like We're Just Making the Sausages. No, it's not. No, I swear. That's the calculation. I mean, Taryn, that's it. That's how you, and that's how many you need. That's the level of confidence you need. That's the margin of error you need. The problem is 243, we determined what these two things are.
Okay.
And then that calculation actually doesn't make sense. I wasn't lying to you. I didn't tell you in the first week of 243. Good Lord, woman. Give me some time to build. I want to build this.
So for this type of thing, like, does the CDC use this type of thing for flu?
They should, and they usually do. And this ties in. So suppose the CDC or any governmental agency wants to test a flu vaccine to see if it works. They draw the random sample of however many. This goes back to Taryn's question, how many? The CDC generally draws huge random samples, 40,000, 50,000, 60,000, many times over many years. And they test. I don't know how they test exactly. I'm not a huge...
Oh, no, I meant like when the spread of the type of flu, because there's several strains of it. And I know that they've been looking at...
You know what? I don't know the answer to that. Debbie, it sounds like he does.
Well, they test, they have to make a prediction based on how the flu the previous year went, which direction it went.
Yeah.
Okay.
There is a good amount of unknown here behind.
Absolutely. Like hurricanes, right?
Sometimes it works and sometimes it
That's why I was curious
Yeah.
if like they use this type of thing to predict those outcomes, because we have like certain ones that come up here, but you know, we're in the cold, so most of the time it dies off. You know, we don't get the heated ones essentially.
Right.
And so there's like several strains of them, and so which one you get is what is put into the vaccines for each area.
And when I moved here, Lyme disease is almost non-existent in Oregon so far. It showed up on the coast, as I'm sure you've heard. It showed up on the coast, and it's on the rise even as of last year. But when I first moved here, I mean, I've had Lyme disease 3 times on the East Coast. It's named Lyme disease because it came from Lyme, Connecticut, which is one of those little East Coast towns up on the map. I remember driving by it, old Lyme, and shuddered. But it doesn't exist here in the Central Oregon yet because it's so damn cold in the winter. We zap all the bacteria, all that Varroa bacteria just gets zapped. But it's on the rise on the coast, and that's only a matter of time until it gets over here. And with global warming and the winter's not getting as cold on average, it might be an issue. But I don't know the direct answer to what you're saying.
No.
It sounds like it's probably like hurricane tracking, where you have the further out you try to predict,
like a
the
strong
more.
likelihood that they would
Oh,
use something.
I almost guarantee you're using the idea, Taryn, of your margin of error. There's a lot, Taryn. Just so you know, that E right there. There's a lot going on with that E. There is so much about that little E, the margin of error. I've actually decided to work it into 105 because it's that important. This year, I just did for you guys. But this idea of a margin of error is so important, being able to measure the uncertainty. Now, this particular, I just grabbed this study a few years ago. Study claims. So when you see those two words, study claims, chances are you're talking about some kind of inferential statistics being done. Because they did a study and they're making a blanket statement